Hello, viewers. In today's session, we are going to discuss an important problem from implicit differentiation, in which we are going to find out the derivative of the given expression with respect to x. That is, we are going to find out the derivative dy over dx. And along with the derivative, we'll also find the equation of the tangent and the normal to the given curve at the given point, that is 0 comma 0, right? So here we have this problem in which we have to find the equation of tangent and normal to the curve sine x plus y is equal to the product of x and y at 0 comma 0, right? So here we are given this implicit expression, and with the help of this implicit expression, we'll find out the slope of the tangent and normal by finding out the derivative dy over dx at the given point as 0 comma 0, right? So let us start. So here we are given the equation of the curve, that is given curve is sine x plus y is equal to xy, right? Now we'll differentiate both sides with respect to x. So the derivative, that is d by dx of sine x plus y is equal to d by dx of xy, right? Now here to get the derivative of sine x plus y with respect to x, we'll make use of the chain rule. So first what we will do, will find the derivative of sine x plus y, which is simply cos of x plus y, and then by chain rule we'll find out the derivative of x plus y with respect to x, right? And in the right hand side we have the product of x and y, and here we'll apply the product rule to get the derivative. So x can be taken as first function, y may be taken as the second one. So we have x, then the derivative of y, and then we have y and derivative of x, right? So here we have cos of x plus y, and the derivative of x plus y is 1 plus dy over dx, because the derivative of x with respect to x is 1, and here we have x dy over dx plus y times 1, because the derivative of x with respect to x is 1, right? Now let us multiply these two quantities with cos x plus y. So we have cos x plus y is plus cos of x plus y, and then we have dy over dx, and here we have x dy over dx plus y, right? Now let us combine the term containing the derivative, that is dy over dx, and taking this term to the right hand side. So we have now cos x plus y, and here we have dy over dx, and then we have minus x dy over dx, and we have y minus cos of x plus y, right? Taking dy over dx common, we have cos x plus y minus x, and then here we have dy over dx. This is equal to y minus cos x plus y, right? So now we have dy over dx is equal to y minus cos x plus y divided by cosine of x plus y minus x, right? So the derivative dy over dx is given by this expression. So now we know that the derivative implies the slope of the tangent to the curve at the given point. So dy over dx may be taken as the slope, that is m, right? Okay, now see here we are given the point 0 comma 0. So we can find out the slope at this point, that is 0 comma 0. So the slope m, that is dy over dx at the point 0 comma 0, which is our origin. So here taking x is equal to 0 and y is equal to 0, we have 0. Then we have cosine of 0 plus 0, and here we have cos of 0 plus 0, and here we have 0, right? So we have 0 minus cos of 0, then we have cosine 0 minus 0, and cos 0 is 1 because cos 0 degrees is 1, so we have 0 minus 1 over 1 minus 0, that is minus 1 over 1, that is minus 1. So the slope of the tangent at this point 0 comma 0 is given by minus 1, right? Okay, so now we have to find the equation of tangent and normal to this curve at 0 comma 0, right? Now see, we know that if we have a curve, say y is equal to f of x, and if we wish to find out the equation of tangent at this point, say p, and this point p is say x1 comma y1, then the equation of tangent is given by y minus y1 over x minus x1 is equal to m, right? Where x1 y1 is the point or the coordinates of the point where the equation of tangent is required, and the value of m is given by the slope of the tangent at that point, right? So in our case x1 is 0 and y1 is equal to 0, and the equation of the normal is given by this line, that is say this is the normal n and this is the tangent t, right? So the equation of normal is given by y minus y1 over x minus x1 is equal to the negative of the reciprocal of the slope, and that is minus 1 over m. So now equation of tangent is given by y minus y1, y1 is 0, x minus x1, x1 is 0, and the slope m is minus 1. So we have now y over x is equal to minus 1. So y is equal to minus x. So we have x plus y is equal to 0, right? So this is the equation of the tangent to this curve at 0 comma 0, right? And we can easily see that this tangent it passes through 0 comma 0 and making an angle of 135 degrees with the positive direction of x-axis, right? Now equation of normal can be obtained by taking x1 equal to 0, y1 is equal to 0. So equation of normal is y minus 0 over x minus 0, and here we have minus 1 over m, m is minus 1, right? So here negative negative get cancelled, we are left with 1. So we have y over x is equal to 1. So the equation of normal is given by y is equal to x, that is x minus y is equal to 0, right? And the important thing about the equation of normal is that it passes through the origin and making an angle of 45 degrees with the positive direction of x-axis, right? So here's this is how by making use of the concept of implicit differentiation, we can find out the derivative, the slope, and the equation of tangent and normal at the given point. Hello viewers, in today's session we are going to discuss an important problem from implicit differentiation, right? So here we have to find the equation of tangent and normal to the a given curve that is sin x minus cos y is equal to x times y at 0 comma pi by 2. So here we are given the equation of a curve in implicit form, right? So here we have sin x minus cos y is equal to xy, and first we'll find out the derivative of y with respect to x, which is the slope of the tangent, and then we'll find out the equation of tangent and normal to the given curve, right? So let us first differentiate both sides with respect to x. So we'll write dy dx, and here we have sin x minus cos y, and here we have dy dx of xy, right? Now see here we have the derivative of sine x. So the derivative of sine x with respect to x is simply cosine x, and then we have the derivative d by dx of cos y, and here we can apply the product rule, right? So here we can take x as the first function and y as the second function. So we have x, then derivative of y, then we have y and derivative of x, right? Okay, so now we have cos x, and then here see we have cos of y. So first we have to differentiate cosine y with respect to y, and then by chain rule we differentiate y with respect to x. So we can also write this fact as d by dy of cos y, and then we write here dy by dx by chain rule. So here we have x dy over dx, and here we have simply y, because the derivative of x with respect to x is 1. So now we have cos x, and here the derivative of cos y with respect to y is minus sin y. Then we have dy by dx, this is x dy over dx plus y. So minus and minus when multiplied together becomes positive. So we have cos x plus sin y dy over dx is equal to x dy over dx plus y, right? Now let us rearrange the terms, and taking the terms containing dy by dx together, so we can now write uh, sin y dy over dx minus x dy over dx. So taking this term to this side and this term to this side, so we have y minus cos of x. So now we can take dy over dx common. So we have sin y minus x, and here we have dy over dx, and this is y minus cos x. So dy over dx is now equal to y minus cos x divided by sin y minus x, right? So by method of implicit differentiation we have obtained the derivative of y with respect to x, right? So now we have to find the slope of the tangent at this point. So let us find out the value of the derivative at this point, that is 0 comma pi by 2, right? So we have here pi by 2, taking y is equal to pi by 2 and x is equal to 0, we have cos of 0, then we have sine of pi by 2 minus 0, right? So this is pi by 2 minus 1, because cosine 0 is 1, sine pi by 2 is 1, and here we have 0, so this is pi minus 2 over 2, right? So the slope of the tangent at this point 0 comma pi by 2 is given by pi minus 2 over 2, right? Now let us find out the equation of tangent and normal. So now the equation of tangent is given by y minus y1 over x minus x1 is equal to m, right? So this is the standard form of the equation of tangent, and here x1 y1 is given by 0 comma pi by 2. So x1 is 0 and y1 is pi by 2, and m is the slope, right? So we have y minus pi by 2 divided by x minus 0, and here we have pi minus 2 over 2, right? So we can now write y minus pi by 2 over x is equal to pi minus 2 over 2. So cross multiplying, so we have 2 times y minus pi by 2, and here we have pi minus 2 times x, right? So we can now write 2y minus pi, and this is x times pi minus 2, right? So we can also write it as 2y is equal to pi plus x times pi minus 2, that is y is equal to x times pi minus 2 over 2 plus pi over 2, right? So this is the equation of tangent to this curve at this point 0 comma pi by 2. Now let us find out the equation of normal. So the equation of normal is given by y minus y1 over x minus x1 is equal to a minus 1 over m, right? Because the slope of the normal is equal to the negative of the reciprocal of the slope of the tangent, right? So we have y minus y1 is pi by 2, and this is x minus 0. So here we have minus 1 over m. M is pi by 2 over 2, right? So now we can take this to the numerator. We have minus 2 over pi minus 2, and x minus 0 is simply x. And now cross multiplying, we have pi minus 2 times y minus pi by 2 is equal to minus 2x, right? So this is y times pi minus 2, then this is pi by 2 minus pi minus 2 is equal to minus 2x. So we can also write it as y times pi minus 2 and minus 2x plus pi by 2, and here we have pi minus 2. So taking this term to the right hand side. Now dividing both sides by pi minus 2, we have y is equal to minus 2 over pi minus 2. Here we have x, and here pi minus 2 get cancelled, so we are left with only pi by 2, right? So this is the required equation of the normal, and this is the equation of tangent.